Request you to occupy the dais, sir. Mr. B. Satyam. Mr. Jagadish, VP Amar Raja Batteries. Mr. Gautam Nalamanda, CEO Photon Energy, Photon Solar. Mr. Madhusudan Rao, CEO Urja Energy Engineering. Welcome. Dr. M.V. Ramana Rao, CMD MIC Electronics Limited. Mr. B. Satyam, CEO Neosilica. Mr. Satyam has got over 20 years of experience in working with big multinational companies based out of US, like AT&T, Unix System Labs, Novell, Deloitte, NetSilica, etc. Presently, he is focusing on innovation and entrepreneurship in smart city and education sectors. Under smart cities, developing multi-utility solutions across utility buildings and plants. In particular to energy sector, he has ventured into building marketing and deploying smart city grid, renewable energy, clean tech solutions, etc. It's our honor and privilege to have you today, Mr. Satyam. So it's over to you, sir, and request you to take over the session. Thank you.
So today we have a wonderful session here on smart energy. Initially, we were going to talk about why smart society and all that. I'm glad actually Sifir has covered that in the introduction itself. So this is a very key session on smart energy, because when you talk about smart cities or smart societies, the biggest layer that we talk about is the layer of networking, electronics, IoT, and ICT. That is the one layer. Now below the layer is where a very critical layer across all the verticals and horizontal is the smart energy. So we'll get into more details in this session. Because when it comes to energy sector, we usually talk about only solar or only utilities or smart grid independently or separately. In this session, we actually brought together thought leaders and also industry leaders together here. Starting with Mr. Jagadish from Amar Raja, the well-known name in battery world in India. And Jagadish has bachelor's in mechanical engineering and did general management and leadership development program in IIM Bangalore. He has 23 years of experience in lead-acid battery industry in the areas of engineering, manufacturing, projects, environment, and operations. And he's currently the Vice President and Head of Technology in Amar Raja. And here is Jagdish here. And he'll be speaking next. Next we have Mr. Gautam Nalamada. Mr. Gautam is the Executive Director and CEO of Photon Energy Systems. They are a leading company in solar energy in India. And especially Mr. Gautam has been in the solar industry for the past 15 years. And their company has solar experience at the rooftop level, at a solution level, and a utility scale level. And across all these, they have deployed some of the best solutions in India. Starting with the highest generating solar plant in India for Inadu Group, and also the largest solar rooftop installations for ISRO. And they have deployed more than 75 megawatts and doing many more projects in India. Very innovative solutions and very with a lot of international experience. Please welcome Mr. Gautam. And Dr. Ramana Rao from, he's the CEO of MIC Electronics. MIC is a popular name in Hyderabad as one of the, they have many solutions. And Dr. Ramana Rao has PhD from JNTU in ECE. And he's a well-known personality in the energy efficient lighting, especially the LED-based lighting. And they have many products, wonderful products, and in the most recent projects in India, where they have deployed LED-based public lighting, They have excellent solutions. And please welcome Dr. Ramana Rao. Thank you. And Mr. Madhusudan Rao is the CEO of Urja Engineering. And they actually lead on energy efficient cooling and heating solutions for industrial and commercial requirements. Primarily, this is what is also known as district heating or district cooling. That means if you actually take individual houses, let's say if you have a township of, let's say, 100 houses, and each house having their own geysers and having their own ACs, that is a lot of wastage of actual resources. And instead, you can actually do in a different way. And Mr. Madhusudan, as their company, Urja Energy, leads in these kind of solutions. And he's a serial entrepreneur, and he also has an advanced diploma in Renewal Energy from Terry University. Please welcome Mr. Madhusudan Rao. One thing that you notice here is all of us are based in Hyderabad, local companies with enormous international experience. And we're all gearing to, we already have a number of installations in the smart energy field, and we're gearing to do a lot more given a chance. So let me quickly run through an introduction. That way the stage is set for what we're going to discuss in this session here. So today in this first session of the conference on smart energy, we're going to address briefly about smart grid technologies, that is utilities, how they get modernized and all, and solar, that is at a rooftop level and also at a multi-megawatt utility scale level, energy storage in a building or across in a substation or in a utility, energy efficiency, that is in terms of LED lighting or device efficiency and also energy efficient solutions, and district heating and cooling, which is what Urja Energy Engineering does. So the purpose of smart energy in a smart society or a smart city is to provide reliable, efficient and affordable energy to all customers, and this is a very important part. It needs to be reliable. That means you need to have energy supply throughout the day, all 24 hours. And it should be efficient, meaning there should not be any energy wastage, either in the generation side or the distribution or on the consumption side. And it should be affordable to the end customers. Today, the customers are already paying, the energy rates have gone up to 6, 7, 8, 9 rupees per unit. And that is probably the highest we can go. If it goes to 12 rupees or 15 rupees, I'm sure most customers will go off the grid, getting into more of a microgrid type solutions. And here, when it comes to smart energy, the important part is each of the solutions that we're talking about, energy storage or utility, smart grid or any of these, there are many, many components that have smart electronics along with ICT, software and communications, that are deployed individually for a specific purpose. And when it comes to smart energy, the idea is that these individual solutions need to integrate horizontally and also vertically and be open for integration. That is a critical part when we talk about smart energy. So for example, if you take this 5-star hotel like Park Hyatt, your lighting loads, your HVAC, and maybe there is some rooftop, and maybe there is a diesel generation, and maybe there is different type of rates and the way in which the grid power is supplied to Park Hyatt. Now, how are these different systems working? Are they working independently, separately, or are they all working together? Now, similarly, the entire street where there are many buildings, are they all working together across to create a neighborhood, to manage a neighborhood peak, right? The peak demand. So this is how the smart energy should evolve. And initially, there will be individual solutions, but eventually they'll be open and they should be integrated. And today we'll discuss some of the issues, why and how they should be integrated. So the energy scenario today in India is that the demand is going to double, whether we like it or not, in the next 20 years, and Hyderabad probably in the next 7 to 10 years. And the power deficit is less than 5%, but compared to other advanced countries, that's about 20% less. And still, there are a lot of issues that are still being open. And now when we talk about renewable energy, now when you look at the generation curve of solar, obviously the generation starts in the morning at 6:30 or so, and ends at the evening at around 5:30, 6:30. Now, how do you integrate this kind of a generation curve into how we consume power, right? They both need to match. And if you take wind, that is much more random. So all these, the random or different kind of generation patterns need to be integrated into the rest of the grid. And comparatively, earlier we used to have some centralized energy plants, like you had a hydel power in Nagarjuna Sagar, or thermal plants in Ramagundam and all that. But now we have many energy sources. Like this building may have 2-3 different energy sources. So integrating many energy sources is going to be extremely difficult. So the net metering is another point that we'll probably cover. And net metering is the way where if you put up rooftop solar, how you can actually put some energy, the generated energy, back into the grid, right? These are all the topics. Now, the issue there with net metering is that if the grid is disconnected, if you have power cut, even if you're producing power in the solar, even if your solar panels are producing power, you still cannot use them. So these are all topics that need to be considered and taken carefully. So what we need in moving forward is we need much more sophisticated solutions and integrated solutions where all these topics are brought together and considered together. And that requires the energy, the utilities, the customers, consultants, the policymakers need to be educated about these advanced scenarios with integrated solutions. So what you need in terms of renewable energy, or let's say in utilities, is you need much more centralized monitoring solutions, because unless you actually get the data across all the plants or all the customers in a utility together into central locations, if you don't have data, you don't know what is happening. You cannot forecast. Today in India, you don't have any models for forecasting energy generation or even energy consumption properly, because the utilities don't have data, nor MNRE, they don't have the data. So, and also when you talk about buildings, which is the place where there is enormous energy consumption, the buildings need to get more active and also green. Typically, when you talk about green buildings, we talk in the form of material. What kind of material should be used and all that. But they need to be active, because the majority of the energy consumption happens after the building comes up. So you need much more active systems to manage energy consumption and also in sync with the energy storage on site, and also with the grid requirements and also the neighborhood requirements. So one of the major aspects that I mentioned earlier is the energy generation is become highly decentralized. So the aspect of distributed energy resources is going to play a major role in the future. Now, if you take a home, today there is every potential for homes and even townships to actually get 20, 30, 50, 70% of their energy requirements from local generation. Now, when we say local generation, we're talking about solar or wind or some combination. And with the help of some storage, you can actually be able to reduce your energy bills and also not depend on, diesel going up and your energy costs going up. Today, people in townships, they actually have these common service charges for the diesel power, and if the diesel power is, the rates are going up, those charges also go up. Whereas when you use solar and all, the fuel cost is going to be delinked from your actual bills. So the more and more, as these systems, as you have these individual systems, they evolve into much more integrated solutions slowly at a building level, neighborhood level, township level, and at a society level, and at a utility level and such. You actually can get into much more advanced economy energy economy. Why did I say energy economy? Today, if I'm generating solar on my rooftop, and if it is going waste, if I'm not using it, can I sell it to my neighbor? Those kinds of applications can actually come up. And that is where energy can be a transaction eventually. Today, energy as a transaction is already happening at a large scale. Open access, when you look at utilities, open access is a huge area where somebody can set up a large plant somewhere, and they can actually sell the energy through open access that the consumers can buy in an open exchange. So now why can't you do as a consumer from your building, from your energy source? So all these aspects are where the energy economy is getting into, and the smart energy solutions are growing into. With this, let me also touch upon water. Water is another place. It is actually resembles very similar to electric. Now, like it or not, the water distribution, let's say in Hyderabad, if you want to look at the amount of losses, they probably have 20–30% of losses. So all our energy bills are loaded with these 20–30% of losses or theft or pilferage, whatever that is. So you need smart grid type of solutions for water also. And in places like Gujarat and all, where there is gas distribution, they would need gas also. So typically when you talk about energy, you talk about water, gas, and electric. So that is how you look at things. So a smart grid for water is also a good potential area in the country. So with this, let me stop my overview presentation and actually welcome each of the speakers to give an overview of what they do from individual areas and how they integrate with the rest of the solutions. Thank you. Actually, this topic is such a huge area. I wish one of these days, if you all agree, we'll actually have a one-day session.
A very good afternoon, ladies and gentlemen. The topic I'm going to talk is on storage of energy. We all know that the demand is not uniform throughout the day. For example, we take a typical home. The demand is more in the morning and it peaks in the nights. Similarly, if we take a city, typical city, again, even though it is the gap between the peak and non-peak is not so wide as compared to a home, but still there is gap between the peak demand and the non-peak demand. Suppose if the government or the generation has to meet the peak demand, that means that we need to actually install a lot of, we need to have a lot of investments into the generation, and that's going to increase the cost of generation or per unit charges of generation. But at the same time, it also actually gives a lot of, what I can say, it puts a lot of pressure on environment. So in order to avoid these things, if we are really looking at a smart solution for smart societies, we need to definitely go in for storage of energy. And if I have to classify or categorize those energy storage into broadly, then there are three categories. One I can say is a grid scale, the other one is the mid scale, and the third one is a small scale. When I talk about this grid scale, mid scale, and small scale, the numbers that I'm attaching, even though they are not, there is no sanctity for that, but what I can say is anything more than 1 megawatt hour constitutes a grid scale, and anything less than 50 kilowatt hours constitute a small scale, and the ones falling in between these two can be termed as mid scale. And if you see what are those application areas that fall into these three categories, grid scale, it is load leveling or peak load shaving and voltage stabilization. Whereas coming to mid-scale, it is village electrification, townships, offices, hospitals, hotels, parks, etc. And when it comes to the small scale, it is mostly the homes, home lighting, and not only lighting, homes basically, and the street lights, the telecom towers or water pumping in the fields, and those sort of things. And what are the technologies that are available to actually store energy? There are numerous technologies. There are many. But only thing is we need to see how much discharge time each of the consumer is looking at versus what is the power that we are looking at. So this is the one which will actually help us to decide which technology we need to go for. If we are looking at, say, very small time discharge, we can look at double layer capacitors, we can look at flywheels. But if you are looking at a mid-range of discharge times, then we can look at nickel-cadmium batteries, we can look at nickel metal hydride, lithium-ion, lead-acid, and all these things. But if you are looking at a very large time, that is more than, say, 2 hours or 5 hours, then we have something like compressed air energy storage, we have pumped hydro storage. So these are the various technologies that are available. So out of all these, it's not necessary that all of these are batteries. Only the mid-range, what I call nickel metal hydride, lithium-ion, nickel-cadmium, lead-acid, they're all the batteries, whereas other things are different forms of storage energy. So if you see the various maturity levels of these storage technologies, the pumped hydro and lead-acid batteries are fairly mature. They are very widely used, and all of us, we know that. But if you see those technologies which are in the demonstration and deployment, yes, there are things like lithium-based batteries, flywheels and sodium sulfur batteries, and also compressed air energy storage. These are the technologies which are in the demonstration and deployment stage. And there are other technologies which are in still R&D. Those are like flow batteries, flywheels at very high speeds, supercapacitors, adiabatic compressed air energy storage. These are all the technologies which are at various levels of maturity. Now, if you see what are the challenges that we face when we are actually selecting a storage system for these smart grid applications, the life of the battery plays a major important role. Then comes the cost per kilowatt hour. Then comes the total cost of operation. Then comes whether the materials are recyclable, which is very important for a smart concept. Then we also need to look at energy density and the safety and reliability of this storage technology. So those being that, what is that Amara Raja has actually done to come out with smart solutions? Yes, we have come out with smart solutions in many of the application areas where we cater to, like Indian Railways, the telecom industry, the power grid industry, automobile industry. So here I have just taken 2 case studies. First case study is about the telecom tower. In the, you may be aware that a couple of years back, the telecom industry has taken over Indian Railways as the major consumer of diesel in this country. If we break down the operation cost of each telecom tower, the energy cost is coming to about 36%. So the telecom tower companies have approached us saying that is there a way we can reduce the energy consumption and make it more viable for them, because at that point of time, none of the telecom operators were really making profits, or they were making very meager profits. So they approached us whether we can do something to reduce that. So then we went and studied various telecom towers, and we came to know that at each and every telecom tower there is a DG set, and you know that the per unit generation of through DG set is somewhere around 16 to 18 rupees per unit as compared to a grid level 6 to 8 rupees. So that is the one which is taking the major cost. So we have done a study to ensure that how we can actually remove this DG set operation so that their whole operation becomes very viable and attractive for the telecom tower companies. And then we have divided into 3 categories depending on the grid power availability. So I will not get into the first and second category. I will directly go on to the third category, wherein the grid was available only for 10 hours and they were operating a DC set for 8 hours, and the balance 8 hours, the battery was taking over the power. So what we had done is we have come out with a new battery. We had developed a new battery which can actually last for the same capacity battery can last for a much longer time. Say from 8 hours, we have increased it to 14 hours. Actually, we could have gone for even more, but only thing is, as you know, the battery requires recharging. Without recharging, the battery cannot actually provide the energy because it's a rechargeable battery. So you need to charge the battery to make it ready for the next discharge whenever there is a power outage. So we need to have a minimum time for these batteries to actually get recharged. And what we have done is, earlier what it was taking something like 12 to 16 hours a day to recharge, we have reduced it to 8 hours. So the grid is available for 10 hours. That means that 8 hours is almost sure. So the battery can be recharged. So the battery was able to take the balance time, and we are able to remove the DC from that site. And what we are, if we see one customer, the Indus Towers, which is the biggest company in tower, telecom towers, it was having something like 110,000, that's 110,000 telecom sites, out of which 40,000 sites we could actually remove the DC set. And that has resulted in savings of about 54 million liters. So which is like 300 crores in terms of rupees. So this is one solution that we have provided to the telecom service providers. And in fact, we have provided even in the category 1 and category 2, but it's that we did not remove the DG set from there. Now coming to the another case study that is similar in the telecom industry itself. The telecom companies, they were actually trying to reduce their capex. So instead of actually having a room and other things built for putting all the equipment inside the room, or to bring down the size of that room, they wanted to have the battery to be installed outdoor. So they went ahead and did it, but only thing is they noticed that the life of the battery is coming down more than half. So that's where again they approached us. And we came out with a solution wherein we have provided an outdoor cabinet. Yeah, we have provided an outdoor cabinet which can actually increase the life of the battery twice or make it even a level with the other, before that outdoor application. Now, are we working? As Amar Raja, are we working with new solutions? Yes, we are working on new solutions. We are looking at lithium-ion batteries. We are looking at lead-acid bipolar batteries. And apart from, in the lead-acid itself, we are looking at new technologies which can actually sustain or be a solution, smart solution to these smart applications. And another area we are working on is smart battery management solution. So it is not necessary or it is not sufficient that we have a battery which can take care of that storage, but we also need to manage that battery so that whenever there is a power, excess power, the battery gets charged. When there is a sufficient power, the battery is cut off from that so that actually it is allowing the load to take and not the battery getting charged and load getting off. So this is another area we are working on. So I come to the last slide of my talk. I just want to leave one thought with all of you. Can DC be used in homes and offices? See, for example, earlier we were having incandescent bulbs, which we have mostly replaced with CFL, and now we are moving towards LED. And we all know that LEDs work on DC power. So right now, whatever the AC power that we get, we convert that into DC and give it to the DC. So there is a conversion of AC to DC, which the energy loss will be somewhere around 20 to 30%. Similarly, we have AC fans in homes, AC powered fans, which consumes about 72 watts as compared to a DC powered fans which are now available in the market, which consumes only 30 watts, less than half. So that's another thing. Then we also have air conditioners. There are many air conditioners which work on DC. Actually, in the market, we call that as inverters, inverter-based ACs. So there are, like that, then we have refrigerators which can come with DC motors. All our laptops, cell phones, everything has DC. So why is that we need to actually work with AC power in our homes? Can we actually look at DC power? So if we can actually convert everything into DC power in a smart society, we can save the power by 40 to 50%. The existing bills can be reduced to that extent. So, and one more advantage is if you go for that, the renewable energies can be straight away used without actually converting that into AC. So the solar power converting, the DC power converting into AC, and then AC power converting to DC, so we lose about 40 to 50%. So all these advantages are there. So if you are really looking at smart solutions, we also need to look at these sort of things. So with that thought, I just end my presentation. Thank you very much. Thank you very much for giving me this opportunity.
Mr. Gautam, to present on solar renewable energy. One thing you'll see that we are rushing through a lot of wonderful concepts.
Yeah, good afternoon, everybody. Thank you, Satyam. I'll quickly go through solar power, mainly solar rooftops and net metering concept, and what our company has been doing. Basically, solar power in smart grids or rooftops are where you use your rooftop to generate power for internal consumption on net metering basis. You have smart inverter which prioritize solar power usage or grid supply. Then load runs off solar power first and then uses grid power. Excess power generated can be fed back to grid, basic concept of net metering. Or you can charge your battery storage. Battery storage costs come down, technology improves. You don't need to worry about grid. Just charge your battery and run your grid. This whole system just connects to your existing bus. You don't need to do any internal wiring changes. And then you have an active monitoring system. We have worked with Satyam's company in this. You monitor your generation, you monitor your load consumption, you monitor your DG set, and the monitor takes care to ensure that if there's any excess load, the DG comes on, the load is run from the battery, and it senses the solar power generation, and is an active monitoring system. It dynamically adjusts the power of the source of the power supply. End of the day, you save your battery, you save your bill, and you have extremely quick payback periods. A simple concept, this is where a utility power and a diesel power, you have an internal bus, and this is solar is connected at that point. Present concept, so there's no maintenance of battery required. If you have battery, you have to take care of the battery maintenance. The actual solar system doesn't have any maintenance. It runs for 25 years as a maintenance free. This is how a net metering concept works. Net metering by definition is just the difference between the energy supplied and energy consumed at the customer metering point. And in a net metering, I like to differ with Satyam here. In a net metering, the grid is the constant backup. So when you say net metering, the grid is the backup. If you want a battery, you don't call it net metering. Then it's off grid. You charge your battery, you run your grid. That is the primary difference between net metering and a storage off grid system. During the daytime, when there's excess generation solar, as you can see from the top, where the consumption is less than the generation, that is transferred to your time of usage where you don't have solar, but the net metering concept as a state allows it, as a grid allows it presently. It lets you use this generated solar at other times of the day also. This is what net metering is. And we do active sensing. We daily monitor the radiation, the daily generation, monthly generation, and we make sure the loads are being used correctly. If there's a shortage of solar, if there's a rainy day, you run your DC or you run on diesel set or on battery. So with an active monitoring software involved, that is a smart component to this whole technology. And solar rooftop is also not only smart technology, is also smart financials. You have a payback of less than 5 years. Your cost of power is 0. After that, there is no increase in power. There is no tariff change. So it makes a lot of financial sense to go for solar. We have done a lot of solar rooftops. Some of the examples of this, large rooftops, basically net metering concepts. The present problem in having a battery storage is, of course, the costs and the technology. We have a lot of hope on lithium-ion in future. Lithium-ion storage comes in. I think we could reduce the net metering and then go into more and more of your own self-storage and consumption. These are some of the concepts which you could do. Parking lots, industrial sheds, everything can be solarized, and then you run your daily consumption from the solar. Rest of the time you do net metering, you have excess generation, you use it rest of the day. Otherwise, even your daily generation is used from solar. Yeah, that's it. Thank you.
Mr. Madhusudan to come and give a presentation. And he's going to talk about district level cooling and heating.
Good afternoon. Excuse me, I'm Madhusudan from Urja Energy. We work in the area of, I have just 3 slides. Satyam told me 3 slides, no more. So just stuck to that. So I'm going to be talking a lot more than what I'm going to show on the screen. We work in the area of energy efficient heating and cooling. And the reason why we work in this area is all the electricity that is produced, I think a bulk of it is used for this purpose. Even the electricity that is produced, 70% of it is produced because you're using heat to produce steam and blah, 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 you get electricity, right? So these are areas we work in. I'll get into district cooling in a bit, but solar steam generation or solar heat generation using concentrators, not for residential or commercial sector mostly, but industrial areas, so I'll keep that out of our discussion. We do energy efficient cooling, in which we use various technologies. One of the technologies we used is called radiant cooling. The thought process we have is, when you talk about energy efficiency, a lot of time it is focused primarily on electricity. How do I get a better motor? Can I use a BLDC this thing? Or can I improve something else so that my kilowatt comes down? We take a step back and say, you know, is there a different way to do that? And that's how we choose each of the technologies we work in. For example, excuse me, radiant cooling. Today, we use air conditioning. Air is cooled and pumped into this room. But is it necessary? What we do is we cool the structure itself, where the temperature of the water that you require to do that is much higher. So if you require, for example, the air conditioning that's working here requires 7 degrees centigrade water, supply water. For the radiant cooling we do, we require 18, 20 degrees centigrade water, which obviously means the compressor has to work less. So it's the same compressor, whether it's inefficient, efficient, whichever you take. If you just use a different way of heat transfer, cooling is a way of heat transfer. Instead of using convection, I use radiation as a means of heat transfer. I use less electricity. Similarly, we also use thermal storage, not just electrical storage. We use storage to store, let's say, cool. Let's say, for lack of a better word, I use ice to store coolness. So what happens if there is a power outage or if there is a higher electricity charge, you can draw from that whenever you require. I'll talk about a case study about that. And lastly, we are working in the area of solar cooling, where you need not use electricity. Electricity is a form of energy that drives a cooling cycle, right? Similarly, I can use another form of energy, which is heat energy, to drive another cycle, which gives you chilled water, which is what you're using here. So these are areas we work in. Of course, there are automation and intelligence that is added to all our projects by using monitoring systems and other optimization techniques. But that's an area I leave it to, companies like Satyam's to add that intelligence. Okay? So we focus in these areas. The other areas we are working, the R&D areas that we are funded and working in are development of a concentrator with thermal storage for industrial process. Because if you remember, one of the graphs that was shown in Mr. Jagdish's presentation was the requirement and the generation when you use solar are never the same. I mean, a process requirement, the heat requirement may be 100 kilowatt, whereas your solar generation will vary. So how do I use solar heat for my industry? Similarly, a large-scale solar heating for maybe not this climate, but for northern climates where I can store heat for residential heating or something like that. We're also developing a small capacity adsorption chiller, which basically uses heat to drive the cooling cycle, which can either cool this entire hotel or a small, I wouldn't say small residence, a small office. Okay. We are also working with other organizations. There's an Indo-US 5-year R&D project where we are an advanced HVAC partner, where we need guinea pigs to try these all new ideas. So those labs are where we try these before we commercialize them. Anyway, so I'll quickly talk about a project that we were involved with, where the building is about 2 lakh square feet. And typical requirement for such buildings is about 700 tons. Now today we are doing with 230 tons. The way we have done it is we figured that if you put a cooling equipment, you put it for peak, let's say 700 tons. Instead of that, I say, the building is not being used in the night, so why don't I run this equipment in the night, generate whatever I need, so that I can use it in the morning. So that's how we reduced, apart from using other technologies like radiant cooling, energy recovery, for lowering the size of the entire equipment. So what happens because of that? Your DG size is reduced to a minimal. Your demand charge is reduced because your connected load comes down. So these are the benefits that you get. Of course, there is a vast area where there is intelligence being built on top of these equipment. And in that, there are various variables as far as the HVAC is concerned, especially when you go to something like a district cooling. For the same project, there's one building. There are 10 other buildings coming. So what we have, with the way we are going ahead with this, is instead of having a plant for each building, you put a central plant and pump water wherever it is required. For example, the administration building works during the day. So pump the chilled water to the administration building. The hostels need cooling mostly during evening hours, night. So use the same equipment to pump the chilled water to those buildings, right? And then there are convention centers or they have seminar halls. The classes are empty when seminar halls is occupied, right? So you use, this is where the intelligence that is built on top of it is useful, where there are other parameters like what are the power costs and all that. So that's what we can either discuss as a panel or I can answer further questions if they are there. Thank you.
That was a very good presentation. I'm sure it actually opened up a lot of opportunities and you see some new ideas, right? Because the solar and all these, we probably are hearing a lot, but this is a new idea. And now I invite Dr. Ramana Rao from Mechatronics, CEO.